Greetings and welcome to the series of lectures on rational expressions and rational functions. Lecture 5.4, Complex Fractions. Let's recall what it is to be a complex fraction with numerical values. So something similar to 3/4 over 5/8. And we can simplify this problem by treating the big fraction bar as division. So the first thing is, we have two methods to do this. One is to multiply by the LCD of both fractions, the LCD of 4 and 8. Well, the LCD of 4 and 8 is 8, so we're going to multiply the numerator, 3/4 by 8. That will give us 24 over 4. And the denominator by 8, 5/8 times 8 is 48. And then we can reduce both of these fractions to 6/5. So we multiply both the numerator and the denominator by the LCD of each of the denominators of the individual fractions. That's method one. Method two is multiplying by the reciprocal of the bottom value. So if we multiply by the reciprocal of the bottom value, it's going to be 3/4 over 5/8. 3/4 multiplied by 8/5. That's 24 over 20, and it's still 6/5. Regardless if you use method 1 or method 2, you should get to the correct solution. Now let's try a more complex problem with rational expressions. And let's use method 1, multiplying both the numerator and the top number and the denominator of the complex fraction, which is the bottom number, by the LCD. The LCD of x and y and x and y is xy. So we want to multiply the whole entire top value by xy and the whole entire bottom value with xy. That will get us xy times 1 is xy over x. Xy times 1 is plus xy over y. I'm just doing the multiplication so far. Xy times 1 is xy over x, and xy times negative 1 is negative xy over y. Now you may be asking, hey, that doesn't look more simplified. But now we're going to reduce. Xy over x is just y. Xy over y is, x. Xy over x is y, and negative xy over y is x. Now there's nothing here that I can pull out to reduce anymore. So my answer is y plus x over y minus x. That's using method 1. Let's try method 2. All over 1x minus 1 over y. Now I'm just going to combine the top number to make it one fraction. So I need to multiply by the LCD, which is xy. So it's going to be xy times 1 over x plus xy over I need a y here, sorry about that. I need an x here, 1 over y, is y over xy plus x over xy. That's going to be y plus x all over xy. That was just the top number. Now let's do the bottom number. I need a y over y for the common denominator, minus x over x for the common denominator. That will give me y over xy minus x over xy. In other words, y minus x over xy. You've got to remember this is a whole big fraction there. Now I'm going to do the multiplication of the reciprocal of the bottom number. Y plus x over xy times xy over y minus x. The denominators, xy goes into xy once, xy goes into xy once, and I'm still left with y plus x all over y minus x. Now, depending on the problem, will kind of determine which method you use. In this case, it looked like multiplying through by the LCD was a little bit faster than going through and finding common denominator, then reducing, then flipping and multiplying by the reciprocal. But that's not always the case. It's just a method that we can use. Let's work through another example. I'm going to use method 1 here, and that is to multiply through the LCD. The LCD of 1 and x squared is x squared. The LCD of 1x and x squared is x squared. So I'm looking at every single denominator. I have 1 under the 1. I have an x squared. I have a 1 under the 1. I have an x. And I have an x squared. I'm looking for the LCD of all of the denominators. Well, the LCD for the numeric values is going to be 1. The LCD of the x variable will be x squared. And I have no other variables, so it's going to be 1x squared or just x squared. So I'm going to multiply both the top by x squared and the bottom by x squared. When that happens, I have x squared times 1. Just do it right here. X squared times negative 4 over x squared is negative 4x squared over x squared. The x squareds cancel out, giving me x squared minus 4 on the top. On the bottom, I have x squared times 1 is x squared minus x squared over x minus 6x squared over x squared. X squareds cancel out. The x will cancel out one of the x's on top. So that gives me x squared minus x minus 6. Now I'm not done. I need to factor both of these and see if I can reduce any more. So x squared minus 4 will be x minus 2, x plus 2. X squared minus x minus 6 will be x minus 3, x minus plus 2. X plus 2 and x plus 2 will cancel out, leaving me with x minus 2 over x minus 3. All right, that was method 1. Let's try method 2 for this problem. All right, I treat each of these, the top and the bottom, separately. I'm just trying to put them under one fraction each. So I just look at the top, and it looks like the common denominator here is x squared. So x squared over x squared. X squared times 1 is x squared minus 4 all over x squared. Now I look at the bottom and I see what is the LCD of 1x and x squared. So it's x squared, so I need to multiply x squared over x squared. Oops. X over x. And the x squared's already there, so it's going to be x squared minus x minus 6 all over x squared. Now I multiply by the reciprocal. Okay, x squared minus 4 all over x squared times x squared over x squared minus x minus 6. And I'm going to go ahead and say that's x plus 2, x minus 2, x plus 3, minus 3, x plus 2, and I'm going to start reducing. Oops, sorry about that. X minus 2, sorry, x plus 2, x plus 2, x squared, x squared. This leaves me with x minus 2 all over x minus 3. Same answer, different method. All right, let's try a new problem. 2 minus 3 over x plus 1/3. Method 1 means I'm going to just concentrate on the complex fraction and multiply by the LCD of all of the denominators. The denominator of 3 is 1. The denominator of x is 1. And the denominator of the 1/3 is 3. So what is the LCD of 1, 1, and 3? Well, it's 3. So I'm going to multiply the top number by 3 as well as the bottom number by 3. Not worried about the 2 yet. 2 minus 3 times 3 is 9. 3 times x is 3x. 3 times 1/3 is 1. Now, this is just subtracting fractions. Right? 2 over 1. I need to find common denominator, so the common denominator is going to be 3x plus 1. 3x plus 1. 3x plus 1. This gives me 2 times 3x plus 1 minus 9 all over 3x plus 1. But I'm not done. I have to do this math. I have to distribute the 2. I have to combine like terms. I got to see if it can be factored, and then I could see if it can be reduced. So there's still a handful of steps I need to take. 2 times 3x is 6x. 2 times 1 is 2 minus 9 all over 3x plus 1. 6x minus 7 all over 3x plus 1. And now I got to look at it. Can it be factored? No. Therefore, that's it. I'm done. There's my answer. That was using method 1. Let's try method 2 on this particular problem. 2 minus 3 over x plus 1/3. First things first, I do need to find one single number down here on the bottom. So I am going to find common denominator here just for the bottom of the complex fraction. So it's 3. Multiply the x by 3 over 3. This will give me 2 minus 3 over 3x plus 1 all over 3. Now, for the complex fraction, I'm going to multiply by the reciprocal. 2 minus 3 over 1, that's the top number, times the reciprocal of the bottom number, 3 over 3x plus 1. Two minus 3 times 3 is 9. 1 times 3x plus 1 is 3x plus 1. And now I carry on like before. I have to find common denominator to be able to do this math. Common denominator between a 1 and a 3x plus 1 is 3x plus 1. Therefore, I'm right back at the step of 3x plus 1 over 3x plus 1. 2 times 3x plus 1 minus 9 all over 3x plus 1. That's going to be the 6x plus 2 minus 9 all over 3x plus 1. And I'm left with 6x minus 7 over 3x plus 1. Same answer, just a different method. about the same length and about the same amount of steps on this problem. Sometimes one method will be shorter to use than the other, but and depends on if you like one method versus the other, which one that you use. But ultimately, it doesn't matter which method you use, you will eventually get to the correct answer if you follow all the steps correctly. Let's work through one more problem, and I'm only going to use the method 1 on this problem. If you want to use method 2, that's fine. You can do that on your own, but I'm going to use method 1. So the first thing is between all of the denominators, I'm just going to write the whole number over 1, I have a 1x, x squared, x cubed. I have a 1, an x, and an x squared for the bottom number. So out of 1x, x squared, and x cubed, what is the LCD? The LCD will be x cubed. That's what I'm going to multiply the top number and the bottom number by, is x cubed. By multiplying by the LCD, we're in essence getting rid of the fractions on the top and the fractions on the bottom. X cubed times 2 is 2x cubed. X cubed times 3 is 3x cubed, but divided by x is 3x squared. X cubed times negative 18 is negative 18x cubed, but divided by x squared is minus 18x. X cubed times negative 27 is negative 27x cubed, but divided by x cubed is negative 27. The top number, no more fractions. Let's deal with the bottom number. X cubed times 2 is 2x cubed. X cubed times 9 is 9x cubed. Divided by x is 9x squared. X cubed times 9 is 9x cubed, but divided by x squared is plus 9x. All right. I have no idea right now, as it looks, can I reduce this fraction? No, I cannot just cross out the x squared, x cubes, the 2x cubed and the 2x cubed. No, there is addition and subtraction here. Therefore, there are multiple terms in the top number, multiple terms in the bottom number, and therefore I cannot just start crossing off things willy-nilly. I need to factor the top and to factor the bottom. Since the top number has 4 terms, I'm going to split them apart into groups. 2x cubed plus 3x squared and negative 18x minus 27, and factor each of those separately. 2x cubed plus 3x squared, they definitely have an x squared in common, leaving 2x plus 3. The negative 18x minus 27, they definitely have a negative in common, and it looks like they have a 9 in common as well. So if I pull out a negative 19 out of negative 18, that leaves 2x. A negative 27 divided by a negative 9 is a positive 3. Now looking at those two groups, it looks like they have a 2x plus 3 in common, 2x plus 3 in common, and then an x squared minus 9. Okay, so here's my top value so far, 2x plus 3 times x squared minus 9. Okay. Let's factor the bottom. All right, 2x cubed plus 9x squared plus 9x. Well, I definitely can factor out an x. 2x squared plus 9x plus 9. I want to see if the 2x squared plus 9x plus 9 is factorable. So, 2 times 9 is 18. I'm looking for two numbers that multiply to 18 but add to 9, looks like 6 and 3. So I can rewrite the middle 9x as plus 6x plus 3x plus 9. Now that I have 4 terms, I can factor by grouping. Again, I'm just going to group the first 2 together and the second 2 together. So let's say 2, this is just my work area, 2x squared plus 6x and 3x plus 9. All right, 2x squared plus 6x, it looks like a 2x can be pulled out, leaving x plus 3. And for the 3x plus 9, it looks like a 3 can be factored out, x plus 3. Now looking at those two values, they have the x plus 3 in common, x plus 3 leaving 2x plus 3. So here's my new bottom value. Don't forget this x that's floating around. X plus 3, 2x plus 3. Okay. But there's one more thing I want to look at. This x squared minus 9. That looks like it's factorable as well. 2x plus 3. And this is x minus 3, x plus 3. It's the difference of perfect squares. X over x plus 3, 2x plus 3. Now everything is factored. I just need to see what they both have in common, both the numerator and the denominator. It looks like they both have a 2x plus 3, and it looks like they both have an x plus 3. So my final looks like x minus 3 all over x. A little bit long, a little bit lengthy, but if you follow each step, one step at a time, then the process will get you to the right answer. It's just learning the process and what step comes next. And yes, I do believe this is a complex problem, but as long as we follow the steps at our fingertips, then we'll be able to get to the right answer in, I don't know, a handful of steps there. Maybe there was about 6 steps. And a lot of factoring. All right, so that's it for this lecture. Until next time, be seeing you.